Either addition or subtraction, the error in the final result. Essentially, I told there has to be some error, some uncertainty. Very beautiful law. The law says either you add any two quantities, any miscalculation in calculating the escape velocity. Hello students, this is SDsir again, getting you all committed with errors. But this class, I have also thought to give you all a solution for whatever errors you have committed. Yes, my today's session will involve techniques rather than techniques, laws that will help you to eradicate errors. Just to recall few aspects of my previous discussion, where we defined error, we told error is an uncertainty in measurement. And mathematically, it is calculated as the actual value difference the measured value. And we also told there are two classes or classification of errors. One what we call systematic errors and the other one we call random errors. And we spoke quite interestingly in depth about those. Now, going to my today's concept, the hero of million hearts, Virat Kohli, with his fabulous drive. But my dear students, if his hand-eye coordination is not precise, the stumps will be blowing out, which means because of the lack of precision, error comes into picture. If he is not able to gauge the pace of a fast bowler, within the lack of seconds, the bails are all flying. Error. See, a beautiful concept as to how I can compare error with a batsman. I have taught you what is an error. Now let us learn precisely and mathematically how to calculate errors. Dear students, there are three rules which are defined on error calculations. Three rules which will help me to calculate errors, out of which I will start learning the first one. Rule 1 says, when two quantities are added or subtracted, it says, when two quantities are added or subtracted. So please to understand, my first rule is the specification of errors during addition or subtraction of quantities. So when two quantities are added or subtracted, the absolute error in the final result. So when you add two quantities or when you subtract two quantities, essentially I told there has to be some error, some uncertainty. Here, the error in the final result after addition or subtraction is called absolute error. So, absolute error in the final result is the sum of absolute errors in the individual quantities. Very beautiful law. The law says either you add any two quantities or you subtract any two quantities. I don't bother. Irrespective of addition or irrespective of subtraction, the error which appears in the final result, the so-called absolute error, should be the sum of individual errors present in the quantities. It is not that I am subtracting two quantities, therefore I should say my absolute error in the result should be the difference. No. Either you add any two quantities or you subtract two quantities, the error in the final result should be the sum of the errors in the actual quantities. Now, how do I better understand this law? I can understand this law by considering an example. I will work out an example so that you understand the law better. Now, the example says, thermometer measures the temperature of two bodies as 20 degrees Celsius plus or minus 0.5 degrees Celsius. So, the first temperature measured T1 is 20 degrees Celsius plus or minus 0.5 degrees Celsius. My dear students, please to understand this 20 degrees Celsius is the measured value, is the measured temperature, and anything with plus or minus is what is called as error. Any quantity that is expressed or measured with plus or minus symbol is called as an error, which means the precision or accuracy of measurement of temperature here is 20 plus or minus 0.5 degrees Celsius. So how much of error is present? Plus or minus 0.5 degrees Celsius. And the temperature of the second body T2 equals 50 degrees Celsius plus or minus 0.5 degrees Celsius. Again here the error is plus or minus 0.5 degrees Celsius, from which I have to calculate the temperature difference between the two bodies. So temperature of the first body is measured as 20 degrees Celsius plus or minus 0.5 degrees Celsius, So how much is the error? Plus or minus 0.5 degrees Celsius in the first case. Second case T2, 50 degrees Celsius plus or minus 0.5 degrees Celsius, where again the error is plus or minus 0.5 degrees Celsius. I have to find the temperature difference. So I say delta T is the temperature difference, which is T2 minus T1. Difference between the temperature difference T2 minus T1, which is actually 50 degrees Celsius minus 20 degrees Celsius. Initially, I subtract the two measured values, find the difference between two measured values. Now, what about the error? Plus or minus 0.5 degrees Celsius, plus or minus 0.5 degrees Celsius. 50 minus 20. Yeah, this is not the error. This is the measured value. I am finding the difference. 30 degrees Celsius. Now follow. What about the error? Although I am subtracting the measured values, when it comes to errors, either you add two quantities or you subtract two quantities. The final error has to be the sum of the individual errors. Therefore, I write plus or minus 0.5 plus 0.5, 1 degree Celsius. No, sir, we have subtracted. Wouldn't the error get subtracted? No. The rule has clearly told, either you are adding two quantities or subtracting two quantities. The error which appears in the final result, the so-called absolute error, should always be the sum of individual errors. So ನೀವಿಲ್ಲಿ ನೆನ್ಪಿಟ್ಕೋಬೇಕಾಗಿರೋದು ಏನಂದ್ರೆ, ನೀವು ಎರಡು ಕ್ವಾಂಟಿಟಿಗಳನ್ನ ಆಡ್ ಮಾಡ್ತಿರಬಹುದು ಅಥವಾ ಎರಡು ಕ್ವಾಂಟಿಟಿಗಳನ್ನ ಸಬ್ಟ್ರಾಕ್ಟ್ ಮಾಡ್ತಿರಬಹುದು. ಎರರನ್ನ ಮಾತ್ರ ನೀವು ಆಡೇ ಮಾಡಬೇಕಾಗುತ್ತೆ. So either addition or subtraction, the error in the final result is the sum of the errors in the individual quantities. Now, going to the second rule, again a beautiful picture where it shows launching of a rocket. My dear students, any miscalculation in calculating the escape velocity, the rocket is blown out. It will not reach the orbit but will fly into space. See how important calculation of error becomes. Slightest miscalculation might lead to the largest of impacts. Second rule. Rules 2 says, when two quantities are multiplied or divided. So my second rule, dear students, is with respect to multiplication or division. First rule was with respect to addition or subtraction. Second rule is with respect to multiplication or division. the relative error in the final result. Now see, if you multiply or divide, the error you get is called relative error. When you add or subtract, the error was called absolute error. When you multiply or divide, it is called as relative error. It is the sum of the relative errors in the individual quantities. How beautiful. See here, still you may multiply or divide irrespective of the operation performed, either multiplication or division. Still the error in the final result, what did I call that as? The relative error is still the sum of the individual errors. So all throughout, either I may be concerned about absolute error, or I may be concerned about relative error. Any operation performed, the final result is the sum of the individual errors. Again, how do I use it as a platform to calculate relative error? Again, I take an example here and I say two resistors. Resistors, component of a circuit. You will be studying it in your 12th standard, or you might have studied it in your lower classes also. Nivella tumba churukagiravaru ee generation avaru ಓದ್ ಬಂದಿರ್ತೀರಾ ಇದನ್ನ. Two resistors have resistances 100 plus or minus 50 ohms. So first resistance is 100 plus or minus 50 ohm. Ohm is the unit of resistance. How much is the measured value of resistance? 100 ohms. How much is the error? Sir, I know, sir. Because of plus or minus 50 ohms is the error. So 100 plus or minus 50 ohms. Error is plus or minus 50 ohms. And the value of the next resistance is 200 plus or minus 100 ohms. Again here the error is 200 plus or minus 100 ohms. They are connected in parallel. That you will study when you come to your next class, series and parallel. Calculate the individual equivalent resistance and error involved in the measurement. First I will calculate equivalent resistance. Formula ille kottidare. So RP is R1 R2 divided by R1 plus R2. All these formulas and all detailed next class, but now I will use this as a tool to calculate errors. So RP equals R1 R2 divided by R1 plus R2. Is this formula involving a symbol like this? This is called delta, a symbol which represents error. No, this is only RP equals R1 R2 divided by R1 plus R2. There is no error calculation here. It is simply the calculation of equivalent resistance. So when I substitute, R1 is 100 into R2 is 200 divided by 100 plus 200. So if you calculate, it turns out to be 66.6 ohms. You can just use your calculators. So my equivalent resistance, still I have not computed the error. Equivalent resistance is 66.6 ohms. Now I will be calculating the error in the calculation. How much of error has occurred in the calculation? This is the formula already given to calculate the error. If you observe, there is delta R symbol. Delta means error. Delta RP, error in the final resistance. That is what I have to calculate. So, delta RP equals, I take R square P to the numerator. So, R square P, this is delta R1 divided by R1 square plus, again, R square P delta R2 divided by R2 square. I have just rearranged the terms so that I want error. Delta RP, that is what I want on the left hand side. And this is equal to, I put all the measured values on one side. R1P divided by R1 whole square into delta R1 plus, again, RP whole square divided by R2 whole square into delta R2. I know the value of RP 66.6. I know the value of R1. I know how much is delta R1 plus or minus 50. Delta R2 plus or minus 100. When you substitute, error turns out to be 33 plus or minus 33.3. Therefore, the final resistance is 66.6 plus or minus 33.3 ohms. So my dear students, please observe on this calculation again, I may have multiplied two quantities or divided them. The error in the final result is still the sum of the errors in the individual results. Hope you have understood the two laws. I have one here as an assignment for you. Please try to solve this using law 2. Be thorough with the two laws. When I come to the next session, I will creep in error again, but the third method or the third rule to solve it will be introduced. Until then, stay safe. Thank you.